Right, so I'm Rachel Cunningham. I'm second year marine science student at Falmouth Marine School, and this is my project, is localisation of biceptal macrocephalids using passive acoustic monitoring, a reliable form of distance estimation for mitigation. So I'll be working in conjunction with Sage Measurements, who are my employer. I've worked on several projects as a remote PAM operator for a year and a half. They are specialists in design and manufacture of underwater acoustic and visual systems for mitigation for a number of industries, but mainly for oil, gas and renewables. So the aims of my research and my underlying rationale. The use of sound is extremely important to many marine species, many of which have evolved highly specialised sound producing and receptor organs. Anthropogenic noise in the ocean is vastly increased in recent years, and the potential long and short-term effects are still highly theoretical and not largely known. This project focuses on mitigation procedures used for passive acoustic monitoring for seismic surveys, which can produce noises of up to 230 decibels from each of the 48 air guns that they have deployed in an array. So we're looking at whether localization techniques is accurate enough to mitigate for this, and how this impacts the ethical and cost implications. So this is a click detector. Each of the ellipses here is a detected click. So this is a sperm whale detection. The clicks highlighted in yellow have been picked up automatically by PAMGuard's automated click classifier, whereas the clicks in red have been tracked by the manually tracked by the PAM operator. So these tracked clicks will then show up in the map display. This gives location information for the vessel, for the mitigation zone, which is this circle here in red, and this is the vessel, as well as the array and the hydrophones. So this sperm whale was tracked to just within the mitigation zone, so if this boat had been firing, then mitigation procedures would have been to shut the vessel down. So when the clicks are tracked, bearing lines will appear. There's a right and left ambiguity. And then once there's been enough clicks tracked, then dots will appear to show where they think that is. So my objectives, I'd like to do real-time and post-analysis of sperm whale detections to acquire distance estimations. I want to compare these results to the original distance estimations made at the time of the recording, as well as expert analysis of this data, and then I'll discuss the reliability of the real-time analysis and how this affects the ability to comply with environmental regulations that are set for that area. So my hypothesis is that distance estimation in real time will be significantly less accurate than post-analysis. These are some of the key references, materials and resources that I've used. Obviously software PAMGuard, which is the industry standard passive acoustic monitoring software. There's a couple of books there, Marine Bioacoustics, which has a lot of measurement and generation of sound underwater, as well as how animals use sound and vocalizations. There's a couple of papers here. One's based in the Gulf of Mexico, which is about the effects of seismic on the foraging behaviour of sperm whales, and one in Nova Scotia, and they're two of the areas where my data was collected from. So my methodology, as my data has already been recorded, I'll just be doing analysis of this data. So firstly, we're doing real-time distance estimation of the data sample. Myself and a colleague at Sage will be doing this. And then post-analysis of this data, again, myself and the same colleague, and then expert analysis by the Sage PAM technologist, and then statistical analysis of this data. I'll be using a simple t-test, which will show how dispersed my data is from the mean, as well as hopefully comparing two sets of data at a time using a t-test. Obviously, I'll have to run several comparisons for this. My expected limitations is that I'm reliant on my colleagues to go through some of the data with me, so I have to make sure I allow plenty of time for that, because obviously they'll have their own deadlines and work to do. I'll set my schedule ahead of time. My contingency plan for this is that basically I can amend my schedule as needed, and I can reduce my data set size as well if I don't have enough time to run through the intended amount. My risk assessment is all computer-based work, so iStrain is a factor. At Sage we have a company policy which I'll be adhering to for this. I didn't include an ethical review because my data is indirect, it's secondary data, it wasn't collected for the purpose of this study. And I'll also be looking at ethical implications of seismic within my report as well. So I'll do that. There's some associated research there which I'll be using to help me do this. A lot of seismic surveying and how this affects marine mammals. This is my intended schedule of operations so far. My literary background research will be ongoing until the end of my project. I hope to have all the data with me by the end of the month and have it all analysed by the time we come back for Christmas, so I have plenty of time to run through my statistical analysis and then, like I said, carry on with my literature review and put together my discussion. That's it.